Hey guys, today I'm doing a power jack replacement on an Acer Aspire 3 laptop. This one has a really loose connection where you plug in the power cord and you can kind of wiggle it to make it work and get the laptop to charge the battery and power on. And this is one of the kind of laptops that has a jack that's directly soldered to the board, so there will be soldering involved for this repair. And the first thing you want to do here is remove that big bottom panel. There's some screws that are holding it in that you need to remove. And these are just regular Phillips size screws. You don't need any kind of special screwdriver or anything. And now that I have the screws removed, I'm going to take a thin guitar pick and just go across the edge of the bottom panel, and that's going to pry up the bottom panel a little bit, and you can apply some pressure with your other hand, just kind of pulling up a little bit on it while you're going around with that pry tool. And it doesn't need to be a guitar pick, it can be whatever pry tool you're comfortable with, but this is a pretty thin guitar pick because it's kind of hard to get in there. So once you get that bottom panel off, now you have access to the motherboard and battery and everything underneath. So the first thing I'm going to do here, like I do with every laptop, is remove the battery cable, or detach rather the battery cable. You don't want the laptop to be in sleep mode or something like that when you try to take it apart. And here I'm just going to remove the SSD. And now I'm going to detach the speaker and the CMOS and the touchpad and the keyboard and all the cables that are going into the motherboard there, Wi-Fi, etc. And things like the keyboard and the touchpad, it's a little flip up, flip down lock style connector. You just take your fingernails or the flathead, just like I'm doing right here, and you just kind of pop up that little connector. It either goes up or down, it doesn't come off, and that's the lock unlock position. And here I'm just going to remove the fan cable. Sorry my hands are in the way, but I'm just taking my thumb and the flathead on each side of that cable and just prying it out. And then there's two screws that hold in the fan. And there I'm just taking my thumb on each side of that video cable and just giving even force to remove that. And now I'm removing a couple screws on the hinge. The hinge folds over the motherboard, kind of where the jack is, so to remove the motherboard you have to remove the hinge screws and then pry up a little bit on the hinge to get that motherboard free. So there's a big cable that's connecting the motherboard to the I/O board, and that hard drive caddy is going over the motherboard cable, so there's really no good way to remove it properly, so it's just safe to remove the caddy here. So there's 4 screws that hold that caddy down. That's for like another replacement drive or an add-on drive. So here I'm just going to push that back, and then now I can get access to that cable. I'm just making sure none of the cables are getting in the way there. And then now I have the motherboard out, and you can see that power jack that needs to be replaced. There's no obvious signs of physical damage with this one, but when you plug it in, it's just incredibly loose and it doesn't fit well. It's very distinct. And so now I'm going to desolder the old piece and resolder a new one on. And the first thing I like to do here is take some flux and add it to the jack area, to each one of those through holes. This is really going to help break up the solder and get that solder flowing. I found, especially with newer laptops over the last 5-10 years, it's just really difficult to get these jacks out, so adding flux is almost a must these days. And I'm heating up my soldering iron to about 750 degrees, pretty typical soldering temperature. I'm using a Hako FX888D. I'll have the link in the description for all the equipment that I'm using. And now I'm just going to take some solder and just try to get these holes, these 5 through holes, just flowing. It's much easier to desolder when you have fresh flux and fresh solder in those holes. It just doesn't want to come out unless you do that. And even when you do the flux and the solder, it still doesn't really want to come out too well. So here I'm taking some of that desoldering braid or wick and just going to remove as much solder as possible from these through holes. You can also use a desoldering pump, either a mechanical one or a manual or an automatic one. I prefer the braid, but whatever works for you to do your desoldering is just fine. And on the tip of my soldering iron, I don't have that traditional kind of skinny needle head tip. I have what's called like a flathead tip, or what's called a chisel tip. And that chisel tip is really nice for these kind of rectangular through holes and sits in there perfectly and gets that through hole heated up nicely. So if you have a soldering iron, it's not working, you don't feel like that hole is getting heated up or melted at all, that could be your issue. Having that chisel tip is incredibly important when you're doing the desoldering. And that's another reason I really don't like the pump. The pump is kind of a circular thing as well, and it doesn't really work too well on these rectangle style DC jack through holes. And sometimes if this process doesn't get all the solder out of the through holes, you might need to repeat it and do again, add some more flux, add some more solder. Sometimes I have to do that too to get that thing all the way out of there. The solder is very reluctant to come out, so don't get frustrated. It's just something I've done thousands of times and it's still kind of difficult to get that solder out. And if the solder really doesn't want to come out, I resort to the hot air soldering station, which I'll be using in this video, to kind of put the final touches on removing that jack. You know, you can get almost all the solder out of there, but even if there's still a little bit left, you know, you don't want to pry that jack out. You want it to come out nice and smooth and not pulling on it. If you pull the jack out when there's not enough solder removed, you can risk damaging the through hole. There's a little barrel that's going through that hole. It's like a metal barrel, and it can rip out with the pin, and once you do that, you know, you've kind of ruined the motherboard. So just be really careful when removing the jack. And here I'm just going to put some 99% alcohol on it to clean it up and get it ready for the hot air station. You know, it's just really difficult to get that solder to come out, and with the hot air it just makes my life much easier. So once I get that jack removed with the hot air station, I can go back to the desoldering braid and just clean up those open holes. And so here I'm just putting some Kapton tape or heat tape on those vital components that are next to the jack. If you don't do that, you can risk damaging the motherboard with those components that are near it. You could blow off those teeny tiny little resistors or whatever they are. So here with this hot air station, I'm going at about 400 degrees, and these Acer, small Acer jacks come out pretty quick with the hot air. I'm kind of about an inch away roughly from that motherboard with my hot air gun. And I'm just trying to go over each one of those holes evenly to try to disperse the heat and get that jack, get the solder from the jack flowing, and it'll just kind of fall out here. So as you can see, not much time. We got most of the solder out before the hot air, which is good. And now that jack will just kind of come falling right out once you have it. And you don't want to do too high of a temperature on that thing, you can damage it, or too high with the blower. And so now I'm going to go back with my desoldering braid and add some flux and try to clean up these holes. This is much easier with the jack removed. Once you have the jack out of there, you can really get that chisel tip inside that through hole nicely, and the solder will come up much easier versus when the jack is in there. So here I'm just kind of I'm laying that chisel tip even on on the side of it to try to get a better angle for that through hole. The more heat you can get dispersed over that through hole, the better the solder is going to come out. So trying it at an angle or trying it at this angle to try to get that chisel tip inside the through hole there is really helpful. And now I've got enough solder removed, I'm ready to put the new jack in. Just make sure that you put it on the correct side. Sometimes I leave my Kapton tape on like this just so I don't forget which side it was. Just kind of a tip if you don't do this all the time. And here I'm just putting my my pliers underneath the jack to kind of keep it level and stable. If I just lay it down on the bench, that jack can kind of will come off being level, or it could fall out while you're soldering it. So putting up something underneath it to hold it into place is good. And here I'm just adding more flux as well. Flux is great, it's going to help that solder flow through nicely to each side. Alright, this thing's all set to go. I'm just going to clean it up again with that 99% alcohol. Get it looking nice. And here's the finished product. A nice fresh jack repaired on an Acer Aspire 3. Thanks so much for watching, guys. If you have any questions, just leave me a comment below. Have a good day.